we're going to assume we're in a court of law. Okay, another application, forensic science. Okay, now if somebody is guilty, they normally let's say we have a suspect. Okay, suspect should be presumed innocent until proven guilty. You understand what I mean? Okay, now we want to figure out what is the probability that a suspect is guilty, okay, given the evidence. Okay, right now, I'm actually G represent guilty, E represent evidence. Now, if I want to rewrite this, I'm actually going to switch it. I'm actually going to have E given G multiplied by the probability of G or divided by probability of evidence. The probability of evidence is going to be a total probability. Now, this is prior. Do you know the belief? Because the prosecutor believes that the accused is guilty. That is their prior belief. That's why this is, you can see, the prior belief is not a conditional probability. But the likelihood and the posterior, they are conditional probability. Does that make sense to you right now? Okay, now, do you know what this guy is trying to say? Okay, we've seen evidence. What is the probability that the accused is guilty? But when you take a look at this guy, okay, when accused has been found guilty, what is the probability of the evidence? This is not the same as this. And when you take a look at this now, if I want to rewrite this, I'm actually going to write this multiplied by this. This guy, so it's always a member of this guy. So I'm actually going to write E giving G, the probability of G, plus I'm going to write E giving now guilty. I'm actually going to add the complement of guilty multiplied by the complement of guilty. Take a look at that. This is Bayes' theorem now. Is there any question here? Now, this is in forensic analysis. In fact, I'm going to give you an example. That was a celebrated case in 1995 in the United States involving O.J. Simpson. Has anybody heard about that case before? O.J. Simpson was alleged of, murdering, his former, his ex-wife because of the fact that he normally molests, And let me tell you this, that very case was actually popular throughout the world, and forensic analysis was applied, statistical knowledge was applied, and stuff like that. But at the end of the day, I'm actually going to tell you the way the case goes. So the idea of a Bayes theorem can also apply. Now, this is forensic analysis. I'm going to go into another application, which is quality control. Number 3, quality control. Okay. Now, what is the probability that a product is defective? Okay. Given failed test. Of course, in any manufacturing industry, I want to believe they have a quality control office, and what they're going to do, they're going to make sure that whatever they produce actually go through a quality test. Now, you've already tested a particular product and the product failed. Okay, now you want to figure out what is the probability that that product is defective. Okay, now this is going to be equal to the probability of failed test given defective, okay, multiplied by probability of defective divided by probability of failed test. Now, the probability of failed test is a total probability. Why is it total probability? Because we got two conditions. There's possibility a product could fail a test and be defective. A product could fail a test and maybe it's not defective. Does that make sense? Okay, so that is why if we continue like what I've been writing, you're actually going to see. So lastly, I'm going to go into financial market analysis, the financial market analysis, where I actually want to talk about the probability that maybe the price of a stock will increase given the past performance. Okay, increase price stock given past performance. Okay, so now given past performance, I want to find the probability that the price stock is going to. So similarly, without wasting my time, let me just say if this is PI given P, okay, where I represent increased price and P, past performance. So this is going to be P given I, okay, multiplied by that, divided by the probability of P. And the probability of past performance is actually going to be a total probability. Okay, we could have a past, it could perform well in the past and the price may increase or not. Okay, now, if you now understand what I have here right now, I can now walk you through examples. Work example. Of course, we're still gonna walk you through those work examples on Friday in the lab. Now, take a look at this example right now. Okay, take a look at this example right now. Okay, in a screening for a certain disease, the probability that any person wrongly get a positive result is 0.05. The probability that a diseased person wrongly gets a negative result is 0.002. You know, in diagnosis, there's something that we call false positive. I don't know that you've heard about that. We have a false positive, we got a false negative, and that is the reason why we cannot trust our equipment 100%. And whenever we have a doubt, okay, when we have a doubt, then we need to find probability. Because probability is having a doubt. Does that make sense? Okay, so now here, the overall rate of the disease in the population being screened is 1%. That overall rate that is 1%, that's a prior that I talk about the other time. Now the question now say, if my test give a positive result, what is the probability that I actually have the disease? Okay, the idea of a Bayes theorem can be used here. So if I were you, I'm going to try that question. Maybe part of assignment too. But I'm going to quickly move to the Bayes architecture. Like I said, take a look at this guy. The PA high, that's a prior probability. The prior probability could be more than one, depending on the numbers of events you're talking about. Then take a look at this. That is a likelihood probability. Okay. Now, the combination of the prior and the likelihood will give you the posterior probability. According to Reverend Thomas Bayes, posterior probability is better than just having a prior or just having a likelihood because you've combined the two. Now, and another thing I wanted to take, to pay attention to, prior probabilities comes in form of a marginals. Marginals. When I say marginals, what do I mean? Unconditional probability. That's what we mean by marginal. Okay? Prior probability is always unconditional probability. But you know what? The likelihood and the posterior, the two of them are a conditional probability. Okay, now for general case, just like what I did yesterday, this is a formula because we could have a situation where we got so many events, A1 up to AN. Okay, so that is that. Now, another thing I want to walk you through. Please, I need you to pay attention now. I want to discuss a Bayes theorem in odd form. And this particular formula, because when O.J. Simpson was alleged in 1995, because the murder took place in 1994, June 12th, when O.J. Simpson was actually alleged of being responsible for the killing of his former wife because of the history that did not favor Simpson, because Simpson normally molests, abuse his wife. And the Simpson lawyer was trying to belittle the evidence because he argued statistically. The Simpson lawyer argued statistically that it is only few of husbands who abuse their wife, they eventually murder them. They are not many. He was actually arguing, on that fact. But do you know that we actually use a Bayes theorem we use this Bayes rule in art form to be able to establish the fact that, the fact that Simpson abused his wife is relevant, it's relevant to the case, because the Simpson lawyer was trying to say that was not relevant. Okay, and this was actually used to prove statistically that the fact that a man abuses his wife, and when the wife eventually turned out to be murdered, then the husband can be accused